सनलाइट से मिरर का फोकस कैसे फाइंड करते हैं, ये एक्सपेरिमेंट देख लो. In just the next few minutes, we're going to completely master this concept. I promise you'll never forget it again.
Okay, so let's jump right in with a super simple but really powerful experiment that you can actually do yourself. All you're going to need is a concave mirror, a tiny piece of paper, and of course, a little bit of sunshine. So the idea here is actually pretty simple. You see, the sun is so far away that by the time its light rays get to us, they're basically parallel to each other. We're going to use this piece of paper like a little movie screen, right? And we're trying to catch the sun's image. The trick is to find that one perfect spot, that one point where the image is the absolute sharpest, tiniest, and brightest point of light you can get.
Now, that tiny bright spot you found, it's not just some random dot. It is super important in the world of optics. It actually tells us something really fundamental about the mirror itself. So, let's give it a proper name, shall we?
ये जो सबसे bright dot है ना, this is what we call the focus of the mirror. We usually write it with a capital F. It's that special magical point where all those parallel rays from the sun meet up, or as we say in physics, they converge after bouncing off the mirror.
Okay, so now let's talk about distance. The very center of the mirror's shiny surface, that's called the pole, and we mark it with a P. Now, if you take a ruler and measure the distance from this pole to that bright spot on your paper, the focus, that specific distance is what we call the focal length, and we use a small f for that. It's one of the most important properties of any curved mirror.
And this leads us to a really simple but incredibly powerful formula, R equals 2F. Trust me, you will see this in your exams. But here's the cool part. Why is it true? Just imagine your mirror is a tiny piece cut from a giant, hollow glass ball. The radius of that huge ball is r, the radius of curvature. Well, it's just a rule of physics and geometry that parallel rays hitting this kind of curve will always meet up exactly halfway between the mirror's surface and the center of that imaginary ball. That's why the focal length, f, is always exactly half of the radius, r. Pretty cool, right?
All right, so we figured out how a concave mirror works, how it gathers light. But what happens with the other type of mirror, a convex one? How does it handle those same parallel rays? Let's take a look.
So here's the crucial point, the big difference you have to remember. Concave mirrors are converging mirrors. They bring all the rays together to a real focus. It's real because you can actually catch it on a screen just like we did with the paper. Convex mirrors, though, they do the opposite. They're diverging mirrors. They spread the light rays out. The rays only look like they're coming from a point behind the mirror, and since you can't actually put a piece of paper back there and catch the spot, we call it a virtual focus.
Okay, let's think for a second about what happens around that tiny bright spot. The experiment shows us more than just where the focus is. Think back to when you were moving the paper back and forth. What did you see?
You definitely noticed this during the experiment, right? As you moved the paper, the spot of light changed size. It got smaller and sharper, hit that perfect minimum size right at the focus, and then if you kept going, it got bigger and blurrier again. This observation is actually key to understanding how images are formed in general.
And this brings us to a super common point of confusion for students. You might be thinking, okay, we found the image of the sun at the focus. So does that mean the image of any object will always form right there at the focal point?
The answer is a big, clear no. That focus point is a very special place. It's reserved only for incoming rays that are parallel to the mirror's main axis. The only reason it worked for the sun is because the sun is so incredibly far away that its rays are parallel. If you bring an object closer, like a candle, its image will form at all sorts of different points.
Chalo, let's wrap this up with the most important part for your exams. Let's talk about the common mistakes people make and some killer tips that'll help you score full marks on this topic. So pay close attention here.
Okay, please be careful with these. First, don't rush the experiment. If you don't find the absolute smallest, sharpest point, you'll get the wrong focal length. Second, always remember to measure from the pole, the center of the mirror, not from the edge. And finally, please don't mix up the properties of concave and convex mirrors. These little mistakes can cost you big marks, especially in your practicals and when you're drawing diagrams.
You should probably write these down. Seriously. When you're writing your answer, use the correct technical words. Say that parallel rays converge. Always state the formula, R equals 2F. And when you draw a diagram, make sure it is neat, everything is labeled, and you always show the shaded, non-reflecting side of the mirror. I'm telling you, if you include these details, your teacher is going to be very, very impressed.
Look, if you remember nothing else from our little chat today, just remember this one golden line. Parallel rays, after reflecting from a concave mirror, meet at the focus. This single idea is the foundation for almost everything in optics. ये experiment समझ लिया, तो optics strong हो जाएगा.